Says here, a space truss consists of members joined together at their ends to form a stable three-dimensional structure. So a 3D truss is basically a space truss. So let's look at this. Very easy. It says here, determine the forces acting in the members of the space truss shown in figure. Indicate whether the members are in tension or compression. Okay, looking at this figure here looks very complicated. And I did not say that you have to do method of section. Very complicated to do method of section here. You do method of joint. Method of joint is where you can pick any one joint. The rest is easy. Let me show you. Remember what we've got here. Let me see what we've got here. We've got support here. We've got support here. We've got another support here. We've got support here, and we've got two active forces. So let's look at as joint A. Where's joint A? That's joint A. Let's look at joint A. So at joint A, what do we have in joint A? Let me take a bigger picture here. Yes, let's look at bigger picture here. Joint A, I've got an active force. I've got another force along y-axis. I've got another force here along z-axis, and I've got this active force along x-axis. The only force which is not in the plane is this one, which is AE. Okay, now we don't know AE. So I need this in force vector form, in vector form. So I have got the position vector. And from position vector, I can get the force vector for AE. Am I right?
Yes, sir.
Yes, sir.
So I can write AE. I can write AE in vector form, which means in I, J, and K form. I can write that for AE. Okay. The rest of the three are already in vector form, like this. The active one. The active one is 4I because it's in the x direction. Where's the x direction? That's the x direction. So let's look in more detail. Vector A. That's the Fibonacci vector A. I need this in vector form. I'll get a unit vector. I get it in vector form. Once I've got vector form, sum for the forces x, y, z. What I've got is I've got my AC. I've got my AC. I've got my AE. I've got my AE. I've got FAB. I've got FAB. I've got three. Clear?
Sir, according to this, FAC and FAE were zero vectors, right? Like zero force.
Yes, you cannot assume. You cannot assume. The calculation is telling you. Okay. You cannot
so,
like look at it and say, yes, sorry.
Yeah. So we couldn't have told this directly from looking at the diagram.
From looking at the diagram, is basically the collinear one, and we've got two members with no external forces acting on it.
Yep.
By looking at it. Well, if you do the calculation, you will get the same answer. You'll get zero answer. Okay.
Okay.
Now let's look at joint B. Joint B, interesting. Let's look at the bigger picture of joint B. Let's see where joint B is. Okay, so let's look at joint B now. So joint B. So joint B, again, I've got this along x-axis, I've got this along y and z-axis, I've got this also along z-axis. This I can convert it to vector form because it's in a plane x, so it's in a plane zy. So I've got this distance and I've got this distance. So yes, it's a two component. Okay. So I can write BE in vector IJK form. Okay. And I've got another one here. Again, I can write in IKJ form. There's no ZK for it because it's in the XY plane. But anyway, when you do the calculation, it will be very clear to you. So let's look at point B. That's my point B. Look, it clearly tells you it's in the XZ plane. And if you look at the RB, it is in the XY plane. So there are two components. Anyway, you can write it in scalar form also now, rather than writing in vector form. You can write, because there are only two components, this component and this component. For this one, you got this component and this component. So you can write in scalar form, but you can write in vector form also, it's your point. And you do the sums, you get your answers out. So relatively easy, okay? There's no rocket science here. So remember, if you got a 3D truss, it's method of joints I would recommend, okay? Go for method of joints, that's relatively easy. As the last one, determine the force in member AB. That's my AB. AD, that's my AD. And AC, that's my AC here. Or the space truss and state, if the member attached, I mean the first W is vertical. Where is that? That's an active force. So common sense tells me I should not draw the fiber diagram of D. I can do the fiber diagram of D, B, C, and it becomes a lengthy calculation. But it's obvious I should draw the fiber diagram of pin A, because then I will have three forces and one active force on pin A. And those those members, I have to convert this in vector form. I've got all the dimensions. You do know position vector, and then in the vector form. So that's the fiber diagram of point A, and you get your answers out. No rocket science. Is that clear?
Yes, sir.